Hey guys, this is the start of first of two videos. I need to make sure you understand compound inequalities, and once I've done compound inequalities, I'll do a video on absolute value inequalities. So let's go ahead and get started on that. All right, so compound inequalities deal with the word and or. Okay, and means intersection or overlapping. Or means either one or both. So just an example in words, if I say that Bree and Chablis are going to be going to the registrar's office, that means both of them are going to the registrar's office. All right? If I say it another way and I say Bree or Chablis is going to the registrar's office, then one of them might be going or both of them could be going. Okay? So how does that ring out in terms of inequalities? So let's look at that. I'm going to go through all of the examples that you could have with and then I'm going to go through all of the examples that you can have with or. So let's start off with and. So let's say that I had x less than 9 and x greater than or equal to 3. So the way these are set up is called using the 3-line method. So I'm going to draw 3 lines, and I'm going to put the first inequality on the first line, the second inequality on the second line, and then I'm going to put the answer on the third line, which is the and. Okay, so this line is the answer. Don't do anything fancy. I'll have these set up for you on the test on Tuesday. So I'm just going to use my numbers 3 and 9. So if I want to do x less than 9, that's going to be parentheses to the left of 9. And if I want to do x greater than or equal to 3, I'm going to do a bracket and 3 to the right. So when I look at this, I'm going to use a marker to color what they have in common. Where do these two graphs overlap? Okay, these two graphs overlap right here in the middle. So when I come down here, I'm going to put the answer as what they have in common, which is right here in the middle. Now here, the 3 is going to get a bracket, and over here, the 9 is going to get parentheses. So the and for that compound inequality is going to be from 3 to 9. All right, so let's look at another one. Let's say that I have x greater than 5 and x greater than 31. Okay, so if I have x greater than 5, x greater than 31, and then I want to look at the and. All right, so I've got 5 and 31. Okay, so greater than 5 would be parentheses to the right of 5. X greater than 31 would be parentheses to the right of 31. And then when I go to look at what they have in common this time, they have this area over here to the right in common. So when I come down to do the answer, I put what they have in common, which is parentheses on the 31 to the right of 31. So the interval notation for that would be from 31 to infinity. All right, so let's do the other side. What if I have one that is x less than or equal to 0 and x less than 6? All right, so if I come down here, I'm going to do x less than or equal to 0, x less than 6, and then the and. All right, so don't be real fancy with the graphs again. X less than or equal to 0 is a bracket on 0 shaded to the left. X less than 6 is going to be parentheses on 6 shaded to the left. Now when I look at what these two graphs have in common, they have this area over here to the left in common. So when I come down to do the answer, it's going to be a bracket and then this area shaded to the left, which would be from negative infinity to 0 with a bracket. All right, so let's do one more. What if I have x less than negative 3 and x greater than 5? All right, so if I come to do my 3 lines, and I've got x less than negative 3, x greater than 5, and then I want to do the and. All right, so here's negative 3, here's 5. I want to do x less than negative 3, which would be parentheses to the left of negative 3. X greater than 5 would be parentheses to the right of 5. Now when I go to look at where they overlap, there's no overlap, okay? So they don't overlap. All right, so when I come down to do the and, I'm not going to put anything on that line because there's no area on that graph where they overlap. So the answer to this one is actually a blank number line because there is no solution as to where they overlap. So those are all of the and possibilities. So let's look at one way that it's set up that is an and, but it doesn't look like an and. So this one is a compound inequality with, I call it 3 sides. So let's say I had negative 3 less than 2x plus 1 less than or equal to 9. So if I looked at this and I didn't look at that left negative 3 and that left less than, I would have 2x plus 1 less than or equal to 9. So to solve that equation, I would subtract 1 from both sides and divide by 2. But like I said, this is like having 3 sides. So if I have subtract 1, I'm not only going to subtract it from the right-hand side, but I'm also going to subtract it from the left-hand side. So I would have negative 4 less than 2x less than or equal to 8. So when I do the division, I've got divide by 2. So I'm not only going to divide by 2 on the right-hand side, I'm going to divide by 2 on the left-hand side so that I get negative 2 less than x less than or equal to 4. This is nothing but an and statement, okay? This is an and statement, and we can just go ahead and do the number line because it's kind of done it for us in terms of the 3 number line system. All right, so see how the x is trapped between the negative 2 and it's trapped between the 4. So I'm going to trap my graph between the negative 2 and the positive 4. And the negative 2 is going to get a parentheses because of this symbol. And it's going to get a bracket on this side because of this symbol. So that I've got negative 2 to 4. And that's just a compound inequality and compound inequality that's written as one whole big problem. All right, so let's go to the ORs. All right, so what I'm going to do is I'm actually going to start with the end of the ands and work my way backwards because they kind of see different things. All right, so let's say that I had x less than 5 or x greater than 11. Okay, so if I set up my 3 number lines and I've got x less than 5, x greater than 11, and I want to do the OR. So I've got 5 and 11. So x less than 5 is going to be parentheses to the left. X greater than 11 is parentheses to the right. So when I'm coming to do my shading this time, remember it only has to satisfy one of the graphs. So the answer is actually what's in both graphs. Okay, so what I'm shading is I'm shading everything in this graph, and I'm shading everything that's in this graph. So when I come down to do my answer, it's going to be everything that I shaded here, everything that I shaded here. So when I was doing the interval notation, remember I talked that we would have one of these later, and here it is. All right, so you're going to read this from left to right. So it starts at negative infinity. It goes to 5 and makes a stop. Skips some space. So the way we do skip some space is a union. All right, and then it picks up at 11 and it goes to infinity. Okay, and that's the way that one is written. Let's do the other two one-sided ones. So let's say that I have x greater than 5 or x greater than 9. All right, so if I set up my two numbers on my number lines, 5 and 9, and I want to do x greater than 5, x greater than 9, and then the OR. All right, so x greater than 5 is parentheses to the right. X greater than 9 is parentheses to the right. So when I come to do my shading, I'm shading everything that's in both graphs. So if I shade everything that's in this first graph, and then I shade everything that's in the second graph, my answer is going to be everything that's green. All right, now don't worry about the symbol here. You don't need to put it on this number line. Since it's covered here, it's covered down here, so you don't need to make any distinction. So my answer in terms of interval notation is from 5 to infinity. All right, so let's do one that's on the other side so that you can see that. What if I've got x less than 3 or x less than or equal to 7? So if I'm doing my 3 number line, I've got x less than 3, x less than or equal to 7, and then the OR. All right, so I've got 3 and I've got 7. So x less than 3 is a parentheses to the left. X less than or equal to 7 is a bracket to the left. So when I'm shading, since it's OR, I'm shading everything in both graphs. So I'm shading everything to the left here, and I'm shading everything to the left here. So when I come down to do my answer, it's going to be bracket everything to the left of 7. So my interval notation would be from negative infinity to 7 bracket. Now, the last one for compound inequalities is the extreme of no solution. All right, so let's say that I have x greater than 2 or x less than 9. So if I come down and do my 3 number line, I've got x greater than 2, x less than 9, and then the or. So I've got 2, I've got 9. All right, so x greater than 2 is going to be parentheses to the right. X less than 9 is going to be parentheses to the left. Now remember, or says shade everything that's in both graphs. So I'm shading everything that's in this graph, and I'm shading everything that's in the second graph. What have I got shaded there? Well, I have the entire number line shaded. All right, so when I come down here, I'm going to shade the entire number line. And you can that kind of makes sense, because a number is, every number is either greater than 2 or it's less than 9. There's no number I can't fit that doesn't answer one of those two questions as a true statement. So when I do that, that's every number on the number line, which would be from negative infinity to positive infinity. And that is compound inequalities. Now the next lesson is on absolute value inequalities, and they also use the 3-line method, and they use and or. So I'm going to stop with this video and move over to the absolute value inequalities video, which is section 2.7. Thanks, guys.